So, do you know that Java doesn't allow pass by reference? Only it allows pass by values when it is calling some method to do some function. And why is it so? Because of the security concerns. Like if you pass by reference, which means you have something like pointers which directly access the memory. And you might also know that Java doesn't have the concept of pointers like C and C++ because of the security reasons. Again, because if you have pointers, it can directly access the memory, right? Like we have seen in C and C++. So, and it is not safe, right, to directly access the memory. That is why Java allows only pass by value and not pass by reference. And when you say pass by value, you might also mean that if I pass a value into a code, then it should not change the original value. Like it would be better if I give an example. So let's dive into the example. So here, if you look at this particular code, which is nothing but we have created a public, we have created experiment one file in which we have a main method. In the main method, we are having a variable a is having the initial value 5, and we are calling a method named as modify, which and modify is actually making some change in the a, right? It is making like a is equals to a into 8, right? And if we print the value here, what what would be the output? And sorry, if we print the value in the main method, what would be the output? So let's see the output. So as you can see here, when we pass the value a, it is being converted to like 8 into 5, which is nothing but 40. But again, from the main method, when we are printing the value a, it is 5 as usual. Why? Because again, as we have mentioned, the value a here is passed by value, not by its reference. So there is no change in the value of a. It is just the change is just limited to this particular method. And when we say like there is no change, how can we imagine in the memory level? Let's see the memory level. So imagine we are having our stack here this way, the stack, and in the stack we are having our so initially we have the main method in the stack where the variable a is assigned to a value um, 5, right? And now in the stack again there comes another situation where this particular main function called another function called modify, as we have seen in the program previously. And this particular function is accessing a, and it is making it as 8 into 5, which is nothing but a is equals to 40. Okay. So generally what happens here is when we call a method, the method creates its own space for its local variables. It does not refer to the same local variable, okay? It creates its own space for the local variables. That is the reason why when we call modify a is equals modify method, the value of a is equals to 5 is actually being copied there, okay? It's not being referred into the what we say it, no, we are not passing the reference, we are just copying the value from here to this method, and this method can make any change in that value which does not refer, which does not change the value here. And you might ask, there is no kind of heap intervention here. Generally primitives are not, stored in heap. If you take here a is declared as int, the primitive data types in Java, they are not stored in heap. But in some situations, like if you have an object, if you have an object like suppose if you have a class like student, and where student is having some age, like students having some int age. Okay, student is having some age and some other values. Now here, as you can see, this is a class. So when it comes to class, and if we create an object for this class, like student s1 is equals to student. So now when we create an object, obviously when we create an object, the object's memory is allocated in the heap. So collectively this whole int age and some extra fields and properties here, for this particular class the memory is created in heap. So in that case we can say that primitives or the memory for the primitives is actually allocated in the heap. So that's another situation. Okay, so now just look at this image. So I have actually represented this particular class and object in the form of stack and heap. So generally the memory for this object s1 is allocated in the heap, which is this part of the memory. But the object name which is pointing to this memory is actually stored in stack. So generally in reality it's not just like pointing like this, it stores the address of this heap. Honestly speaking, this heap memory, this particular chunk of memory is having some address, and this s1 here it stores the address, which we can also express for our understanding as this pointer. Okay, so until now it's fine with the pass by value. Now we can see that due to the pass by value reason a is not modified. Okay, now let's look into the objects case. So now look at this particular code. In this particular code we are having a class called student with a field name, and we created an object for the student where we given the name java, and we are calling a method now. The method actually changes the name into Python. Whatever the name we give in the parameter, it changes it into Python. And we're printing the what we say name in the main method again. So according to pause by value theory, what should be the output? So when we are pausing by value, of course the value should not change. So here we are expecting that the Java should not change. So the output should be Java, but it's not the case. Let's see. So the here the thing is printed as Python. Why? What is this? I mean, you said Java does not support pass by reference, but here why does the value change then? The real reason is in case of objects. Like here we are taking an object. In case of an objects like arrays also, the reference is copied, not the value. In case of primitives, the value is copied, but when it comes to the case of this, the reference is copied. So I will show in a diagrammatical way. If we represent this diagram, if we can represent the previous situation in a diagram, this is it. We have created an object st, and initially we have assigned the name, the field name st.name is equals to java. This is okay, this is done. And what happens when we actually call this particular method? The method here is change of st. What happens after calling this method is the reference. So when we actually give the function call to the modify method from this main method using this object, then what actually happens is the reference to this object's memory is being passed here. So this particular method in the modify also points to this same heap memory. So in result of this, when we change s dot name is equals to Python, like in this particular line s dot name is equals to Python, then automatically here instead of Java it becomes Python. Okay, and after this when we call, okay, and after the function is completed, the method is executed. And when we even come back to this main method, here if we are trying to print st.name, it's printing Python because the the actual memory reference values change. It's not like the previous case, where the what we say here the value is being copied. No, in case of objects, the reference is copied. Okay, so due to that, it still look like passed by reference, but it's not passed by reference. It is passed by value, but passed by value with copy of reference. That is why the actual variable changes. And now a small twist to the story here. So we have seen the case of pause by value in primitives and in objects, and we have understood the major difference. And now try to answer this code where there is small change in this particular code, which is in this method. In this change method. Okay, I have written previously as modify. Okay, it's change method. In this change method, we are not just changing the variable now, we are first doing some other function, which is we are creating the new object. So what would be the output now? The output the output would be Java. Why? Because yes, why? Because here, okay, it is passed by value, the reference is being copied. Like when we say is change of st, the st's reference is copied here, but we are creating another new object. Okay, we are creating another new object, and in the other new object we are making the changes. So the original object reference does not change. When we call this particular line, when this particular line executes, a new memory is created, of course, because we know that this keyword new refers to the allocation of new memory for that particular object, right? So here the pass by value is actually happening, but inside this change, the memory is address is changed. So the change is in the new memory address, so the original object is affect unchanged. Okay, let's see the diagrammatical way. Now according to the recent scenario we have seen, due to the due to the line s is equals to new student, what here is happening is, due to this particular line s, okay, due to the line s is equals to new student, this s is pointing to a complete new memory chunk in the heap. And when we change s dot name is equals to Python, okay, initially here it is Java in the initial thing, and when we change the s dot name is equals to Python, the entire change is actually in a new memory space. Okay, it doesn't affect the original one. Hope you understood. So that is it. So to summarize it, Java is strictly passed by value. For primitive types, the value itself is copied, but whereas for the objects, the reference value is copied. So due to this particular reason, when we actually pass objects, we feel like it is passed by reference, but the reality is not. It is not passed by reference, it is actually passed by value, but due to the copy of reference, the changes are made in the actual object. And for primitives, the memory is in the stack, whereas for objects, it is in the heap, but not strictly. Okay, the primitives memory allocation could also be in the heap when the primitives are actually present inside a class or inside an object. So that is it. Thank you for watching the video.